Now let's take a look at the flyweight pattern. In boxing, a flyweight is actually a lighter weight class by a significant margin than a lightweight. I haven't been a flyweight since I was about 9 years old, and I'm not actually a big person. So a flyweight is really, really light. And that gives you the idea behind what we're going to try to do with our code. We're going to try to make it really lightweight. So the problem we're addressing is we need a lot of copies of an object. The object might be somewhat complex and might use a fair amount of memory or perhaps has some performance issues. And the more copies of that object we create, the more memory we use, and maybe we do a lot more database queries and we cause performance issues. So you could see this happening if you have some sort of web application that has a list of users, just lots and lots of users, thousands of users. And if we actually pulled them all up and created objects for each one of the users, that would be bad enough. But then, if we actually do that for every time the user is accessed, so we have multiple copies of the same user spread out all over the app, then we can have real problems in terms of memory and performance. The same sort of thing can apply to game objects. Lots of games have repetitive objects that might be obstacles to the game, and those objects are used time and time again. If the game was to actually create a new object every single time it used it, then it would have a whole lot of memory bloat and it would probably slow down. Or you could also think about posts in a social app. If you've taken a look at a Twitter timeline, it can be really lengthy, but Twitter only shows you what you need to see as you scroll along. But also, it's showing the same posts to a lot of different people. So it doesn't really want to reproduce that object for every single person who's looking at that post. It would like to use the same object in memory. So that's what the flyweight does. The flyweight is a shared object that can be used in multiple contexts simultaneously. So what that means is that instead of recreating instances every time someone wants to access an object, the instances are reused or shared. Now here's the side effect of that, of course. They're shared objects. So if there's an operation that makes a change to that object, it's changing the same object for all of the users that are sharing it. So in general, we're probably going to use the flyweight a lot for read-only objects, for like a timeline post, or for a user that we're displaying, or perhaps for that object in a game that doesn't actually change. And for our implementation, we're going to use a dictionary of objects. And we'll add the object to the dictionary if it's not already there. But if it is in the dictionary, we'll use the object that's already stored in the dictionary. So instead of having multiple creation steps, we're actually going to just pass around multiple references to the same object. So there are two areas, particularly if we're looking at database-driven applications, that this can help. If we're talking about a user that's stored in a database, every time we access the user, we don't want to do a database query to find the user. We want to effectively have cached that user. So we're going to pull the user out of the database, and we're going to do that once. And then we're going to put that user into the dictionary. And of course, store it in the dictionary keyed under a unique ID. And we'll pass that single reference to that user around into multiple instances of that application. So we're going to reuse that object throughout the application. We won't requery the database, and we also won't have multiple memory footprints for that user. Now again, the side effect for that is that everyone is sharing the same user, and also when we're talking about database-driven, if we're not requerying the user, if there are any changes to that user, then they're not necessarily seen if they were done under a non-shared object. So you may have to put in some sort of methodology for refreshing the cache. In taking a look at the flyweight pattern, a lot of times they say that it's not well used, and perhaps that's true in the strictest sense. But if you think about it in terms of caching, caching is obviously used quite a lot, and the flyweight pattern is very similar to that idea. So in our example, we're going to have a user list. Our application has lots of users. We're very popular. We have thousands of users, and the users are used throughout the application. So we don't have just one area of the application that we're using a user. We have it all over the place, in all sorts of pages and operations. So we have all sorts of things that use a user object. Of course, we would like to limit our memory footprint. More memory is more dollars, and it slows up the application. So we only want to create a user when it's used, and we don't want to recreate the user time and time again. So we have a normal user class. Everything's as you might expect. It has normal properties like username, password, first name, last name, and then it has one little additional thing, a follower list. And depending on how popular this user is, that could be very heavy. So this class has a bit of a heavy footprint. You might argue with the implementation and design of that, but that's what we have. We have a fairly heavy user class, and if we reproduce it, we're going to have some memory issues. So we then have a user factory class, and the purpose of the user factory is to supply users as needed to the application. The user factory is going to have that internal user dictionary that we talked about, and the user factory will have a single method, getUser. It'll check that dictionary, and if the user that we're looking for is in the dictionary, it'll return that instance of the user. So it'll only be returning that single reference. If the user's not in the dictionary yet, then it will create a new user, and it'll add that user to the dictionary for future reuse, and of course, return it for the getUser method. So there are two aspects to this. One is the reuse from the dictionary of that user object, and the second is the lazy loading of the user. We're not actually adding all of the users in the database into this dictionary, even though no one has ever asked for the users. We're only getting the user the first time it's necessary. Basically, we're doing it just in time and not quite too late. So we're only going to get the user when someone requests the user, and then after we get it, we're going to keep it for future use. And it's a really simple class diagram. We have our basic user class, which has some properties and that followers property that could be quite chunky. And then we have our user factory, and it has fields for users, which is going to be our dictionary of users, and then just an internal field for users count. And that's just to keep track of how many users we actually have in the dictionary at any time. That's not really required, it's more for demonstration purposes. And we have a single method called getUser. So that's what the flyweight looks like. And the whole purpose of it is to just minimize the number of copies of an object that you have and to minimize the amount of times that you create that new object.